for the vision talk by Mr. Joe Jensen. Over to you, sir.
For some, it's a phrase that conjures up an uncomfortable sense of risk and uncertainty. For others, it represents the only sure path to experience life's full potential. But when it comes to the impact of artificial intelligence on the future of IoT, there's really only one way to look at it. The edge is where the action is. It's the edge where unprecedented amounts of data will not only be generated and collected, but where the critical decisions directing autonomous vehicles and devices must be determined in a matter of milliseconds. Where businesses and enterprises worldwide will seek to carve out their own unique competitive advantages with the power of data. And while the immense value of the data center will continue to grow for decades to come, many of AI's most promising contributions to the IoT revolution will require the development and distribution of specialized compute resources. Resources designed to enable an exciting new era of opportunity and growth for businesses everywhere, and built right into the farthest reaches of the network and its ever-expanding edge. Which is exactly why you can find Intel there today.
Good morning. I'm really excited to be here in Bangalore. Very happy to be invited to speak today. Thank you very much. We see an amazing growth opportunity in IoT. How does it feel to be part of one of the most exciting markets in the world? Great? You guys excited? So if we look at the future of IoT, it's really about having all the right assets and resources to enable businesses to find the value in the data that they generate and collect. Intel's been making investments necessary for us to take advantage of these new requirements in the ability to process, manage, store, and move data. We've expanded our view of the market to be much more inclusive and are now looking at a $300 billion per year TAM. And these investments are paying off and enabling us to make a massive transformation in Intel from being primarily a PC-centric company to really being more data-centric. Just 3 short years ago, only 20% of our businesses were total up revenue, about 20% of our business in data-centric businesses. We closed last year, 2018, at over 50% of our revenue in data-centric businesses. And the future of the company and the future of compute, we believe, is really around data-centric and analytics and AI. IoT is a key part of this. You can see we've got a $30 billion TAM opportunity for Intel in the IoT space as well. But if you look at this, the analysts were actually a bit wrong. This is a complex business. It spans every market sector. Literally any business, any part of the global economy is touched by IoT. Every single industry has nearly an unlimited number of use cases. And as I talk to this industry, I would encourage you to not just talk to your OEM customers, but you got to reach beyond the OEMs to understand the business use cases that their customers need to solve. We've really fundamentally transformed our IoT perspective in the market by reaching beyond the OEMs to understand the business use cases that end users need solutions for. And it's enabled us to deliver much better products. Winning today is not really just about selling a hardware platform. It's not about selling a chip. It's about delivering a complete solution. We win by partnering across the ecosystem. And customers tell us it's a big part of why they pick Intel is our ability to bring these end-to-end capabilities in architecture. It also requires us to partner with tech players in the ISV space, really critical, cloud service providers, as well as solution integrators. You know, the analysts started by talking about IoT as billions. I think the number was 50 billion IoT devices, and they were going to be a bunch of really simple, dumb things, collecting data, spewing it up to the cloud, and all the compute and analytics would be done in the cloud. And today, the analysts realize what we knew all along, that it's much more complex than this. We're focused at Intel really on the industrial or business commercial IoT space, and this is about generating real-time actionable insights for businesses. It's going to require hundreds of high-definition cameras streaming data real-time in places like factories and retail stores. Analyzing that data is going to require storage, compute, and analytics at the edge. Cloud connectivity will still be key, and there's going to be a lot of insights that you want to share at the cloud, but delivering those actionable insights at the edge real-time is going to require the ability to process that data real-time at the edge. Let's take a look at one use case that we did this past year with Alibaba in China. There's a big effort there to bring analytics and AI technology into factories.
When factories rely on human eyes to perform precise inspections, the results can sometimes be less than optimal. In some factories, less than 20% of defects are actually detected. And that means expensive customer returns and wasted machine and worker hours. So we asked ourselves a question. What if Intel's data analytics and high-performance computing technology could enable machines to evaluate product quality on the factory floor while the work is in progress? We turned our eyes towards creating a scalable solution with commercially available hardware and Intel software, and we tested it in the fast-moving China market. It all starts with the camera. A high-definition, off-the-shelf camera is used to inspect the part from all angles. The data streams to an industrial PC, and it's powered by an Intel Core i3, i5, or i7 processor, and these are all compatible with the full suite of Intel-based accelerators. With algorithms created using Intel's OpenVINO, computer vision, and deep learning combined, and we use that to evaluate whether the part passes inspection. Other industrial machines in the factory can be connected to Intel-powered gateways that gather and translate data to standardized formats. Then they transfer that over the network to either the edge server or the cloud for processing. The edge server, powered by Intel Xeon scalable processors, sorts and processes the data using Intel's Industrial Edge Insight software, identifying which images and data streams need to be stored. The edge server acts as a scalable on-premise data center in the factory, processing data from multiple machines, consolidating workloads at the edge, and sharing data with the cloud. Factory workers can use ruggedized tablets to check the status of operations. Data is collected over time and is used to identify and address the root causes of defects. The results mean time and money saved on the factory floor. A proven industrial edge computing platform designed to be scalable, ready for integration into any factory, and already implemented in China.
That single factory builds just 45 parts per hour, and they're still generating 1.2 terabytes per day of raw video. They process that at the edge in real time down to 130 gigabytes a day to generate real-time insights, and then they share metadata back to the cloud for analysis across the entire factory network. This is a massive opportunity. In China alone, there are 700,000 factories with essentially no artificial intelligence, analytics, or data collection whatsoever. So we take a look at where we're focused at Intel. We're not really focused on the things, the little chiclets or small things. The microcontroller class devices aren't where we're focused. Whereas, as I said, we're more focused in the commercial or business IoT space. And this is where we're trying to generate these real-time insights at the edge. We're focusing really on changing the economics and enabling businesses to better harvest this data to generate these insights. This year, 45% of the IoT-generated data will be stored, processed, and acted on at the edge. This architectural shift is actually moving further and further in that direction. You can see from our publicly reported numbers that we're really seeing fantastic growth here. And if you look at the product mix, we've actually got a very rich product mix, and our ASPs for our processors are over $100. So, the IoT market is not just about little small things. It's also about high-performance compute processing at the edge. We have three focus areas of investment in our IoT business. Delivering the right silicon roadmap for high-performance compute at the edge, developing the right technologies for video and vision inference, and then lastly, and I think most importantly, building the technology suite necessarily to aggregate these workloads at the edge, and we'll talk more about all three of these. So from Atom to Xeon, we leverage the technologies that Intel builds in massive scale for commercial IT customers. These technologies have value in the IoT space as well. IoT customers need to make sure they can manage and secure their devices. Those technologies we develop for enterprise, we move those into the IoT space in our business. We adapt our products to fit IoT by certifying them for IoT use conditions, industrial temp ranges, longer duty cycles, etc. We enable a wide range of operating system environments, and we support them with IoT-specific developer tools. We also invest heavily in reference designs and we document customer-driven best-known configurations to share and help lift the industry more quickly. One of the key things we believe is that scalability of our roadmap is critical so that you can get the right level of performance for whatever workload you're trying to serve. So dive a little bit deeper into this. If we look at inference at the edge, we think that really vision is going to change everything. I saw this morning, the 35 or so, big ideas. Maybe this is number 36. We think that vision is going to transform everything, literally everything. By 2021, 82% of all the traffic will be video. Delivering business insights requires the use of vision. If you think about a human, vision or video data is really the key data type for us to observe things. As we go into bringing these kind of real-time AI platforms to the edge, computer vision and delivering insights off that computer vision will be a really critical data type as well. And how is this changing? Well, the cost of compute has fallen dramatically, the cost of cameras has fallen dramatically, and that makes the economics much more attractive now for businesses to implement camera systems and video analytics technologies. And it's really critical that we deliver the right level of performance for these as well. It's not just a matter of saying, hey, I've got my platform, I now want to put some computer vision in, let me drop a big GPU in. A lot of workloads only need a bit more performance. And one of the things we realized if we looked at the compute capabilities we had at Intel from Atom through Xeon, GPUs integrated on the CPU, we've got a range of video inference acceleration products and FPGAs, we realized we had a tremendous amount of compute. And if we could build a tool that would help developers better optimize their algorithm against the Intel hardware platforms, we could deliver some pretty amazing scalability of performance. And so last year we launched the OpenVINO toolkit, and what it does is really enables developers to take the algorithm they developed in the framework of choice that they're using, they can recompile or rerun that algorithm through the Intel toolkit, and it automatically optimizes that algorithm onto the hardware platform that you're landing on. So you could have a platform based on an Intel Core CPU, and you decide to add a couple more cameras to the system, you need a little bit more performance, you can either step up to a bigger CPU, or you could add in a small, inexpensive inference accelerator chip. You have the ability to take that same base algo and run it across a wide range of platforms depending on the performance necessary. We launched this tool in May of 2018, and we already have 15,000 developers trained globally on it. Last month, we also, to really help accelerate the ISV market and the SI market, we have 7 partners who launched PCI Express cards with either arrays of our Movidius inference acceleration silicon or with FPGAs. And that enables these applications to land really quickly on a platform and start delivering those kind of results for developers. Last summer, we were in Computex in Taiwan, and we met 25 of our partners, and nearly everyone were doing solutions with OpenVINO, and the key benefit that they reported are a lot of implementations are going to be one camera, maybe 3 or 4 cameras. That's not arrays, not everything's like a stadium or an airport. And what they found is that they could actually land very nicely these workloads on a basic Intel platform when they optimize through OpenVINO. So take a little bit deeper look at OpenVINO. In this example, we've got, in the very left-hand box, a Xeon, and we took it, and Bill took a base Caffe algorithm on the Caffe framework, and we implemented it using the math kernel library. So this is just kind of the basic Intel CPU and capabilities. And you can see we're doing about 36 frames per second at about 55% CPU utilization. Like I said, last summer we launched OpenVINO. So in the middle box, we take the exact same hardware configuration, no change at all, and we just use this new optimization tool to be able to land that algo, that same algo, on the platform. And you can see that we increased our performance 8x. No difference in the hardware, much, much better performance through optimization and software. Now, say you've got a much more aggressive or much more difficult challenge. Maybe it's a high production volume production line, or you've got a large number of license plates and cars you're trying to track at the same time, and you want to bump the performance up dramatically. Well, now you can drop an FPGA in. What OpenVINO will do is actually create the code to program the FPGA for your algorithm for you. So you don't have to actually create the programming for the FPGA. The OpenVINO toolkit will do that. It'll land your algo and optimize it across the real estate available from the FPGA. And you might say, well, I don't really need 760 frames per second for performance for my application. What would this really make sense? Well, a more likely case would be, for example, 24 camera streams, all running the same resolution and capability as the first box. So on the left, we have the same level of performance, but now we could watch 24 cameras at the same time. And so the amazing part of this is being able to take that OpenVINO toolkit and deliver that kind of optimization and that kind of performance in a way that's really easy for developers to take advantage of. So enabling these kind of vision and analytics workloads and use cases is probably best done in a workload consolidation platform. And our view of this, I think, is if you look at how IT has operated for the past 10 years, it's been about how do I take individual dedicated servers and how do I start to take those workloads and through virtualization consolidate them for better cost efficiency and better manageability. In a typical industrial application, there will be dozens of PLC controllers, these kind of deeply embedded computers, and they're typically scattered throughout a machine and across the production line. We have examples of power plants where there are literally thousands of these PLC controllers. And when we talk to the end customers, one of their challenges is they can't even necessarily find all those PLC controllers. They're distributed across the entire plant. And so when it comes time to do some kind of maintenance or support or something goes down, they rely on tribal knowledge from the maintenance staff to know where these things even are. And so these highly distributed environments are very difficult to manage and support, and it's really kind of, circa 1900s IT technology. With workload consolidation at the edge, we can consolidate these workloads onto a common compute platform and take that kind of old school architecture really into the 21st century of computing. We got a great example in a solar farm, and just one of a lot of examples we've worked with, where they have over 100 solar mirrors to collect solar energy, reflecting them up. And each solar mirror array has its own PLC controller helping control the aiming of that mirror. We're able to take all of those over 100 PLC controllers and virtualize them onto a single Intel Xeon platform. And so now all the compute sits on a common compute platform, and now you have the same technologies available to that OT operations manager that IT has, where they can actually put failover in. So they can put a second Xeon platform there to handle failover. There's enough surplus capacity in the first platform, so if one or two of those virtualized partitions were to go down or crash, it can instantly fail over to another partition. And we're able to deliver much better manageability, better uptime, and a better cost structure. So this trend of aggregating discrete automation controls is really how we see the future of architecture in IoT. We've got a couple interesting examples of this. This next one is an example where we worked with JD.com in China to really revolutionize vending. In China, there's an opportunity for 6 million vending machines in business offices, and this is just to get drinks and snacks during the day at work. They looked at traditional vending machines and they said, this is a really a friction-filled experience for customers. You put your money in, you look at the little corkscrew, maybe the product vends, maybe it doesn't. How could we transform this completely? So in their example, it's really just a refrigerator with a glass door. On the front, there's a video screen for advertising, and there's a camera. And if you want to use the machine, you register your company badge photo with the machine, and as you walk up, it recognizes you and unlocks. So as your customer, you walk up, you open the door, you look at what's in the fridge, just like at home. If you're hungry, you open the fridge, you look at what's in the fridge. There are 5 cameras inside the fridge, and so whatever you reach in and take out, it sees that you took it. If you don't want it, you put it back. The cameras detect that you put it back. Now, for me, I might say, hey, I'm really hungry, and I grab a bag of chips. I look at it, wow, too much sodium. My wife says I shouldn't have a lot of sodium. I put it back. I like the Snickers bar. I pull the Snickers bar out. Wow, too many calories, too much sugar. I put it back, and then I reach in and take an apple and close the door. The system knows I only took the apple. As soon as I close the door, it bills me. Super low friction, great consumer experience. They're getting 40% more sales per machine with this technology. And you might say, wow, this is amazing. How could I afford to go do this in my business? There's no way I could afford it. This machine costs half as much to manufacture and produce as a traditional mechanical vending machine. 6 cameras, 1 Intel compute platform, and the machine is half the cost of traditional vending with better sales per machine. Amazing. Video is going to transform everything. What could you transform with this computer vision technology? The worldwide TAM for vending machines in 2023 is over 10 million units. This is just one simple example of video transformation. Another great example of workload consolidation. Oh, I'm sorry, and if I go back to that platform, what's workload consolidated? There's scales in the shelf to help with accuracy. There are 6 cameras doing a video analytics workload. There's a screen on the front doing an advertising kind of traditional compute workload, and they've got the connectivity to the cloud and payments. And so they've got 4 workloads all running on a common compute platform. Traditionally, those would be run on 4 separate platforms in the system. So the next example of workload consolidation is education. There's a huge opportunity here in India for advanced education technologies as well. You know, these started actually in China with intelligent whiteboards. It's a big digital sign where the teacher could project classroom content, education content to the students. It evolved to where it became interactive, and so now it's touch sensitive. The students can put their content on the screens. It's a much more interactive platform. Well, then they added video broadcasting and decoding and encoding, recording the classrooms or recording the class exercises. And now the next step is they're actually adding cameras for student behavior analytics and teacher analytics. And so as we look at this platform, we've been able to keep adding new workloads to the platform through workload consolidation. We're not adding additional compute platforms. We're not having one platform that's a little low-end chip for the display, another chip to do the video analytics workload, another chip to do the video encode. We're able to put this on a platform, and with workload consolidation, you can even run multiple operating systems on a single platform. So the opportunity for this workload consolidation and computer vision really spans all verticals. I can't think of a single market that isn't going to be transformed with video analytics. You know, whether it's parking lot systems, smart cities, airports, you pick any market or end user space that you can think of. Video analytics technology and a steep curve it's coming down on cost is going to literally change everything. And if you look at how many cameras and how much resolution, Amazon's told us that they're going to have 1,000 cameras in each Whole Foods. JD.com, they have a smaller format store called 7 Fresh in China, very much like a Whole Foods, 400 cameras in every 7 Fresh store. These stores are going to have cameras everywhere. And why? Because again, you want to deliver intelligence at the edge. Human intelligence depends on depends on vision. Putting intelligence at the edge is going to require vision as a key data type and input. You're going to see a massive net increase in the amount of compute MIPS and compute going into every single application. I own the retail business at Intel, take a retail store. The amount of compute in the store has been largely stable for a long time. Point of sale systems, there's a server in the back of the store, fixed kind of level of workload and compute for 10, 15 years. Maybe a little bit of bump with some digital signage going in the store, but pretty much flat and stable. We're now seeing huge increase in the amount of cameras in the store. You're going to see 2, 3, 5, 10x the amount of compute going into every single store. Same thing in factories. That 700,000 factories we talked about in China, they have essentially no compute today. They're going to have a massive amount of computer video analytics running to help drive better efficiency and better yields. So take a look at another quick little video on the verticals.
When it comes to transforming your business, Intel delivers purpose-built technologies and market-ready solutions that provide real-time insights when and where you need them most. And with speedier deployments, consolidated systems, and a built-in foundation of security, you'll find smarter ways of doing business by gaining intelligence from the data of things. In stores, vision technology and robotics help keep track of everything and notify the warehouse what's in and out of stock, so sales associates can use insights to deliver better in-store experiences. Smart cameras are helping factories keep things moving by spotting defective products, unsafe situations, and potential machine meltdowns before they become a real problem. And when it comes to helping improve city life, it's possible to monitor things like traffic and air quality to keep everything running smoothly. The future of your business relies on data. So put your data to work with intelligent solutions based on Intel and start transforming everything today.
So if you look at how this video is going to transform things, a couple simple examples. One is a hospital. And actually, this example is actually a combination of video as well as RFID. But it turns out in the hospital, as we worked with hospitals to try to understand their business problem, what is the biggest problem they have, it turns out that keeping the operating room full and keeping it busy is a huge problem for them. Cleveland Clinic, our first one was in Florida that we worked with. Cleveland Clinic in Florida, they said they were losing $430,000 a week by having the operating system room not fully utilized. And what they wanted to do is be able to track doctors and track patients and make sure that they had patients queued up and the doctors where they needed to be at the right time. And through a combination of RFID and video analytics, they were able to essentially fully book the surgery suite, saving them over $400,000 a week in one hospital. That's one hospital. If you look across the world, retail, we saw an example here in retail. The biggest business problem when you talk to retailers is inventory, either out of stock or too much inventory. Over $1 trillion a year of missed profit in retail globally because of inventory issues. Overstocks that they're selling below cost, $300 billion a year of profit loss on selling overstocks. By understanding your inventory correctly and making sure that the shelf has the correct inventory all the time, they can greatly impact that $1 trillion problem. And again, whatever industry your platforms or your products are going into, I encourage you to get out there, understand what is the business problem that your product is helping to solve. I think back in the early days of IoT, we were very focused on how do we get platforms out there to enable people to collect data. And we kind of forgot or didn't realize that people don't want to buy platforms and put platforms in their factory to collect data if they don't know how to get value from that data. If they don't know how to analyze the data and get an insight that's going to change their business outcome, they're not going to spend any money collecting data. And so whatever you're doing in the IoT space, make sure that you're focusing on how is this platform going to solve an end user problem. Partnering is a big part of this as well. Very, very few partners can do everything really well. What we're finding is the best of breed solutions, the ones that really scale in the market, are the combination of the best ingredients from hardware to software, solution integrators, and the experts to be able to go get these solutions deployed at scale. A big focus for us is building these ecosystem of partners and bringing them together. And we've built a new program to help end users better get to scale and drive their products into commercial volume through what we call market-ready solutions. The market-ready solutions are we take a complete proven system, and this is ingredients typically from 2 or more partners who are working together to deploy a real-world system that's at scale at some customer. We go analyze it, we look at it, how well done is it really stable, robust, is it ready to scale across multiple retailers? And then we bring it into our sales channel, and we compensate our salespeople to go sell that along with our partners. Fantastic increase in our ability to scale. A great example is Zavello. Zavello is a kiosk maker, and they make self-order kiosks for fast food restaurants. Their biggest customer today is McDonald's. With Zavello, they've got a couple other partners, they're the kind of lead, but a couple other ingredient suppliers, and we've been able to take that Zavello market-ready solution out and introduce it to a much larger audience than Zavello as a small company could do on their own. And so to close, really, what does success look like? It's having the right products, the right ecosystem, and the right vertical domain expertise. This relentless cycle of performance and cost improvements is enabling our industry to really unleash these business insights at a more and more cost-effective level every day. Video data is going to be the enabler, we believe, to all of these big business insights. And a key, we think, is delivering the right price performance for these workloads. It's not a matter of, I've got a simple compute platform with no video, and now I drop in a couple $100 accelerator with a lot of power consumption. It's getting those micro steps of performance necessary to deliver the right workload for each platform. A simple example, and I think this is a good example here in India. If you look at retail today, self-checkout systems and checkout systems typically use a laser scanner. Probably no companies in India with the IP making laser scanners with their own IP. The future of scanning, and we're seeing the very tip of the iceberg today, is all of these scanners are going to move to image-based scanning instead of barcode-based scanning. We're seeing most of the systems with 3 or 4 cameras, and the reason they have 3 or 4 cameras is so they can very easily get a great image of the label, so they can tell what the product is quickly, but they can also detect whether the clerk or the self-checkout customer are cheating the system. And by focusing just on the theft reduction alone, there's a massive cost savings benefit to the retailer and a reason for them to switch out and upgrade. So we think actually, for example, in retail, camera-based scanning will replace laser scanning over the next 5 years. And that, again, say look at 3 or 4 cameras per POS system, installed base in the world over 25 million POSs, huge opportunity for camera-based scanning systems. Again, video is going to transform everything. And lastly, how do we deliver these kind of advanced capabilities in a way that the factory, the hospital, the retail store, the city can go manage these assets and operate them efficiently? And we think workload consolidation, like we've seen in IT and the data center, is really inevitable at the edge, and it's going to become a key part of how this data is analyzed at the edge. So with that, thank you very much for having me.
Thank you very much indeed, Joe Jensen, for that keynote, for that vision talk. I'd like to request Mr. Rajesh Ram Mishra, President IESA, to please present a small token of our appreciation to Mr. Joe Jensen. Ladies and gentlemen, I'd like to request all of you to please give him a big round of applause once again. Mr. Rajesh Veerapan from IESA, I'd like to request you to please present Mr. Joe Jensen with a token of our appreciation, and we'd like to thank you for that vision talk.